Okay, we have some participants tonight. Miss Torres. And I can't see the other name. Miss Bauer. Welcome. Can you all
Hi,
hear me?
Mr. Fee.
Hey.
Yes.
Okay. Let me move up my volume a little bit. All right, nice. Y'all came out tonight. Is there anything, y'all have any questions?
Not
I'm just here for a comprehensive overview.
Okay, well, it's hard to give that in an hour. What I have is this key to the final exam review. So one thing I could do is just kind of go through it problem by problem. I did, there was someone who showed up and I probably did 10 problems off of this. I think there's 33 total or 30, 34th. I could repeat, go through it. Oh, it's 35 problems. So the real final exam is going to get cut down a lot, but it's hard to give an example of every kind of problem that could appear.
Could you perhaps start with, because I can go over the Zoom meeting. I couldn't be at the Zoom meeting at 12,
Right.
but could you perhaps start somewhere after where you left off for the other Zoom meeting?
Okay, well, she skipped around a lot, but I think I remember what problems we did at that Zoom meeting. So I could do, if you wanted to watch that and see those problems, I could do some of the others. Would that be okay?
That would be really helpful. Thank you.
That way we try to get most of them in between the two meetings.
Perfect. Thank you.
Okay. So we did number 1 at the 12 o'clock meeting. Why don't I charge into number 2 then?
Okay, thank you.
Okay, sure thing. We'll do that. We'll just go through it problem by problem. If I did it at 12 o'clock, we'll skip it and do some others that we didn't. So we want to solve a quadratic equation here. Solve the final exam review. Solve 6x squared equals 7 minus 19x. So we want to add the 19x over. Subtract the 7 equals 0. Hope y'all remember this from the first of the semester. We want to use the quadratic formula. Do I need to write it down or can I just start plugging and chugging?
I'm okay with plugging and chugging, but I don't know about my friend Angela.
Okay, Ms. Torres, can I
I'm good with it too.
You good with it? Okay. So you have your negative b. Add and subtract your b squared rather than write down 19 squared. I think whatever the heck 19 squared is. It's 361 minus 4 times the a times the c, which is negative 7, divided by twice the a, which is 12. So basically you got a negative 24 times a negative 7 there. 24 times 7 is 168. Negative 19, add and subtract square root 361, add 168. So we're going to see how that came out. 168 add 361 comes up 529. Square root of 529 over 12. I don't, no, actually it does have a root. Looking at the key, just cheated and looked at the key. If we do a square root on that, 529 comes up 23, which means it would have factored, but we don't teach the factoring anymore when you've got a number here. Negative 19, add and subtract 23 over 12. If I'd done the root on that and it come up some nasty decimal, I would have quit at this stage. So negative 19, add 23. Hope we're not going too fast. Hope this rings a bell. That'll be 4. Okay, we got another participant, 4 over 12, which is 1/3. How many people are we up to now? Oh, still got 2, okay. And then we're going to go negative negative 19, subtract 23, divide by 12, and it's going to be negative 42 over 12. Let's see if I can get this more on the page here. Yeah, 42. Okay, so 6 to the 42, 7 times 6, 12, 12, negative 7 halves. I hope that rings a bell.
That's easy
Okay.
for me anyway.
Okay. We did not do number 3. If there's one that's really simple and you don't think you need it, let me know. Otherwise, I'll just charge in. We did not do number 3.
Angela, what do you think? What were your most difficult ones to solve?
It just, to me, it really just depended on like what was going through my head that day. Does that make sense?
Sure. Did you were you okay with the beginning of the semester and it got harder towards the end?
Yeah, I was much better with the beginning of semester.
Me too. I was as well.
Okay, let's see. I don't know what this message is about. Oh, example, somebody's on my Wi-Fi upstairs. Okay, let's see if we're back. All right, well, you want me to just charge into number 3? It's kind of your dream FOIL problem. Foiling out 3 pieces.
Okay.
Well, go ahead.
Are you okay with foils, Angela?
Oh yeah.
I'm okay with foils, Mr. C. Could you skip ahead, please?
Sure, skip ahead. All right, we did not do number 4. And that's you know what to do to solve this. You got to distribute through here, bring these pieces over. You'll set up another quadratic, which we run through the quadratic formula.
What do you say, Angela?
Can we run through that?
Let's do it.
Absolutely. So we're starting with 5x, x minus 2 equals 6, add 3x. And we're trying to solve. So we'll distribute through here, 5x squared, subtract 10x. I'll bring a minus 6 and minus 3x over. When you got squares, letters, and numbers, you want to select everything to one side. Combine your like terms. Looks like negative 13x minus 6 equals 0. Now I've identified my A, my B, and my C. Might factor. I could play around, see if I could create a 2 parentheses FOIL, but we've been charging right into the quadratic formula and I seem to have frozen. Or maybe I'm back. Okay, maybe I'm back. So I guess we'll just charge right into the formula, keep doing it the same way. Positive 13. 13 squared is 169. Minus 4 times the A times the C. All over twice the A, which would be 10. 20 times 6 would be 120. It's going to be 169, add 120. Add 120 all over 10. 120, 169, 269, 289. Maybe I'd better do that in my head. 169, add 120. Add 120. Yep, 289. That smells like a clean root 2. Try not to look at the key. Might be 17. See if I use my ANS key. Yep. Add and subtract 17 over 10. So this would have factored if you'd have figured it out. So same idea, 13, add 17 over 10, 30 over 10, it's 3. 13 minus 17, negative 4, if I do down over 10, which is negative 2/5. Any questions about that? Did that go too fast?
No, you're good.
Okay.
That was good. Thank you.
Sure thing. So
I guess where I get most tripped up is like on number 5 and just um those little number lines there with the open circles and the closed circles.
yeah, this is out of chapter 3. I think they did 3:7. It's got a lot of technical details. Let me write it down. We'll walk through it. Number 5, solve 5 over x plus 3, x minus 7, and we want it greater than or equal to 0. So you start with zeros, top and bottom. And you got to keep track where they come from because it matters. All right, can you tell on the top x minus 5 equals 0? The x would equal 5.
Yes.
Okay. On the bottom, you got both of these pieces equal to 0. They've already factored it for you. That x would be -3. This x would be +7. Questions
Okay.
about that?
None for me.
Okay. But we're going to lay out the number line and we're going to lay these 3 numbers in order. So -3 comes first, then 5, then 7. This is where it gets technical.
One question.
Go ahead.
On the bottom.
Yeah.
Wait, you did it on the top. You did mean to change the signs, right?
Yes,
Okay, I'm just making sure.
that's correct. That's how you find your zeros. You change your sign. See, so in effect, you're adding 5 over here, adding 5. So the 5, your actual 0 is +5. So you can go 5 minus 5 and get 0.
Okay, I'm just making sure because that confuses me knowing it's already negative, and then it goes from positive to negative, and then negative to positive.
Right. See, I'm setting x plus 3 equal.
But I get it now.
Okay, -3. So x is -3. Okay, now this is where it gets technical about putting the open and closed circles on these numbers. I guess I'll do the bottom first. It's the easiest. There's no choice on the bottom. It's always open. You remember that? Why is it always open? It's because if you closed it, that says you could use 7. But you can't use 7. Look up here. You can't use -3 and 7. Because if you did, you'd be divided by 0. Go ahead.
Well, you can use 7 because x equals 7.
Okay.
Right?
X equals 7 and it forms a boundary on the intervals. But you cannot exactly use 7, which is why we label it with an open circle.
Okay, I guess that's where it really confuses me because it says x equals 7. So
I'm just writing that because I'm solving this bottom equal to 0 to find out these numbers.
okay.
Maybe I should say x can't be 7, x can't be -3, but we never really use the not equals.
Okay.
Okay, now at the 5, you see how to tell which it should be? You do have a choice. See from the top, see that or equal to? So 5 is a legal number.
Yes.
If I use 5, I get 5 minus 5, which is 0. 5 minus 5. 5 minus 4, which equals 0 on top, and 0 can be greater than or equal to 0. So you see what kind of circle 5 should have on this problem? I'm looking at the or equal to. The circle should be open or closed?
Closed.
Closed. See, this is going to get very technical. I don't know which of these intervals are actually going to work. but I know I'm going to have brackets on the 5, but parentheses on a 7 and -3 when I finally nail down. All right, so we've gotten this far. Any questions getting this far?
No.
I'm
no
good.
thanks.
Good, okay. Are we ready to test inside each interval then?
Yes.
Okay. So I come over, you pick a random number. You can pick any number you want. I use -2, then I plug it in here and I'm going to check my signs and see if it overall comes up positive. So I'm going to get a -2 subtract 5 over a -2 add 3 and a -2 minus 7. Is that going to come up positive? Remember, I want positive signs are greater than or equal to 0. A negative sign would be less and wouldn't work. Well, can you tell you top is negative? Again, I don't care about the exact number, just the sign. The top, the bottom, the top is negative. This little parentheses is positive. -2 add 3. I give you +1, so that's positive. But this piece is negative. You see, I got basically a negative divided by a negative. That's overall negative on bottom. So I got a negative divided by negative, which is, guess what?
Positive.
Positive. And does it work?
No.
Sure.
Yes, it does.
You see why
Well,
it
it's
does?
greater than or equal to 0. Positive, yes. So
Yes.
negative divided by a negative is positive. So yes, it works.
Yes, this works. And therefore I shade. So my first interval is going to run from -infinity into -3. But I like to do all the intervals and then write it all down at once. Are we ready to do the next one?
Can you get the shading without testing it? Would you know how to shade it without using the test numbers?
Don't see how you would, no, unless you're a real genius and can somehow do this in your head. But you see, that's very hard to teach, doing something in my head. It's tough for you all to see my neurons moving. But
Okay, so there's no way to find the answer without testing it.
yeah, without testing it, either on paper so I can show you or in your head. Yeah, I could go -2 minus 5. Okay, that's negative on top, if you can remember that. -2 at 3, well, that's positive there, and then -2 minus, so that's negative. So I had a negative there, overall positive. So in effect, you're testing it in your head. But that's tough to teach.
I see. That makes sense though now. I did not fully understand that until right now.
Okay. Well, that's why we go over this again. That's the purpose of the final exam, is to go over and over a lot of the same stuff we did to try to give you one last chance to learn it before you pass on from the course and never use this ever again.
I have a question.
I'm so cynical. I'm sorry. Okay, are we ready for the next one?
Yes, but I have a question.
Yes.
When exactly, that way I know how much time I have, is our final exam?
Well, yeah, I'm still working that out. I want to give some time, but I don't want to give all week. So I'm right now thinking of having it ready Wednesday after Thanksgiving. That'd be the Wednesday of finals week, and then due Friday.
So next week, basically?
Yeah, but I was going to hold some Zooms next Monday and Tuesday, at least offer to hold Zooms.
Okay, I'm just making sure, that way I know exactly.
And then after those Zooms were over, assuming people want them, over Monday and Tuesday next week, I was going, yeah, people, see, right now, still before Thanksgiving, everybody's got the Thanksgiving holiday anyway, and then people might not be geared up, have even looked at this final exam, yet. But by next Monday or Tuesday, when they know it's coming Wednesday, they might be a lot more serious about it and want to show up and have more questions.
Okay, thank you.
So I'm thinking right now having it available a week from Wednesday, and make it due Friday. Okay, let's use 0.
Do you always use 0 as an example?
You don't always have to. It's just that 0 is pretty simple to use.
Okay.
But I could use -1, 2, 3, any number in the middle.
In between the -3 and 5.
Anything that's in between, I could use -3/8. I mean, I mean, but
Okay.
so yeah, you try to use something that's pretty simple.
Okay.
So you got a 0 minus 5. See, that's negative. And then you've got a 0 add 3. That's positive. And then you got a 0 minus 7. Well, that's negative. So you got really the same story as over here. Negative on top, overall negative on bottom. They two divide out and give you a positive. So this is a
Yes.
yes. But you see why I cannot do negative infinity into 5. You see why? I can't do this because that would say I could use -3, but I can't use -3. It makes me divide by 0. So I'm going to have to separate these as two separate intervals at the -3. This can't use.
Okay. But you could use negative infinity to -3.
Yes, that's what I'm going to wind up doing. Negative infinity to -3, then go from -3 to 5. But I got to separate it out.
And then you'll use a third interval, right? You'll say
Assuming,
5.
yeah, and then a third.
Assuming it works.
Yeah,
Okay.
assuming it works, might be a third interval. I'm expecting one of these not to work, but at this point, I don't know which one. Between 5 and 7, I guess the only whole number is 6. I guess we'll use that. So if x equals 6, we got 6 minus 5. We got 6 add 3, and 6 minus 7, greater than or equal to 0. Well, you see your top is positive. This piece is positive.
So it
And,
works.
uh,
Yes.
yes. Oh, well, no, this piece is negative. You got one negative.
So no.
This is a no. So I cross that off.
So there's not a third interval.
Wait a minute, I've screwed something up. It just hit me. I knew there's something. Take a look at what I did back on the first interval.
And that's a -7.
Now
Negative.
yeah, I'm sorry I missed you. -2 is on the wrong side of -3. I don't know what I was thinking. It's late tonight. Negative over here.
Yes. I see that too.
Yeah, my fault. We'll see if anybody else watches the video and catches that. I should use -4.
Okay. Let's try that again.
Okay, so try this one again. That's -4 minus 5. See, that's negative on top. Our bottom is -4 add 3. See, that's negative. And then you got a -4 minus 7, and that's negative. Greater than or equal to. So you got 1, 2, 3 negatives.
Negative.
Yeah. Odd number of negatives is negative, so this does not work. Yeah, my fault. I knew something was going off.
So now we have -3 to
So now-
5.
Yeah,
is
right
one of our
now, exactly. So right now, our only answers are between -3 and 5, and we might have this. I guess we use 8. So x equals 8. We'd have 8 minus 5, that's positive. 8 add 3, that's positive. And 8 minus 7, that's positive. Greater than or equal to 0. So yeah, can you see 1, 2, 3 positives? Has to be.
Positive.
And therefore this
Works.
works. All right, now I'm ready to write down the two intervals. So that's my answer. I go between -3 and 5.
Can I answer whether it's brackets or, okay, so the, on -3, 5, to the left of -3, it's a parentheses,
Correct?
brackets on the right of 5,
Yep,
yes?
yep.
And then,
Yes,
it's 7 to infinity.
yep.
And on the left, it is, parentheses.
Yep.
And on the right, it's brackets. No,
No, so that's an
it's
infinity.
parentheses.
It's always parentheses on it.
Right, it's a parentheses.
Yeah.
Yes, yes.
Well, I hope that's finally what I got on the key. Let's see. Ah, yes, it is. Okay. Apologize for the little glitch in there, but we finally got it.
No, it makes sense. That's all that matters.
Yeah, and you can see it's very technical. There's got to be a bracket here because 5 works because it's on the top. 7 and -3 do not work. They come from the bottom. They make you divide by 0.
Okay.
But nevertheless, they're still in the answer because they bound the answers. All right, you want to keep going?
Yes, please.
All right, next one would be 6. I did not do 6 at 12 today. Do y'all need that one done?
Let me see. Solve x minus 4. Sure.
Okay,
Yeah, let's go over that one.
that's an absolute value. Solve twice and then absolute value of x minus, golly, late tonight. 4 and greater than or equal to 12. All right. So you remember you don't distribute through an absolute value, right?
No, I didn't remember that.
Well, remember that. Yeah, it's not this. They use parentheses, that's 2x minus 8.
Okay.
But you cannot, this is absolute value. And it does not work like a parentheses. So all you can do is divide both sides by the 2 because that's multiplied. It says absolute value x minus 4 then is greater than or equal to 6. Now all you can do is make out a number line. You're going to put on a 6, but you're also going to put on the negative of this. This is from chapter 1, I think it was 1.7. With us so far?
Yes.
Are we going to put open or closed circles here?
Open.
Well, take a look at the or equal to.
Closed.
That would make them closed.
Okay.
If there was no or equal to, it would be open.
Okay.
All right, now, you really don't test here. It's really thinking about knowledge of the number line. All right, and the right side is the easiest to see. Basically, the only way to drop it, there's nothing you can, it's not like, x squared and you take a square root or something. There's nothing that undoes this. It's just a matter of seeing, you can kind of think of this as a blob. And if your blob is bigger than 6, it's got to be this side of 6. And that would say that x minus 4 is greater than or equal to 6. I'll call that number 2 because I'm on the left side of the paper. I'll call this one number 1 when I move over here. This says the x's are greater than or equal to 10. I'm going to add 4, add 4.
Why are the x's greater than or equal to 10?
Okay, because of solving this, do you see where I'm getting the x minus 4 greater than or equal to 6?
10 minus 4 is, okay, got it.
So I'm going plus 4 plus 6 plus 4 is 10. The x has got to be bigger than 10. I can plug in some numbers and show you. See, if I use 10,
It makes sense.
makes sense. 11
Yeah.
minus 4 and you'll come out bigger than 6. But if I use 9, see, 9 minus 4 is 5. And the absolute value of 5 will be less than 6. That won't work.
Yes, I mean, it's late for us too. So yes, I get it.
All right, sure thing. Well, see, here's the harder one to see is this side. Because remember, an absolute value of a -7 will be greater than or equal to 6. Because the absolute value takes the number between the bars, which would be 7, greater than or equal to 6. So numbers over here like -7, -8, these work.
Because absolute value is plus or minus?
Absolute value says take the number between the bars. So if I have like a 4 between the bars, then I get 4. If I have a -4 between the bars, I still get 4.
So either way, the bars make it positive.
Either way, the bars make it positive. So it's already positive. It doesn't really do anything. But if it was negative, then it turns it positive. You're taking the value between the bars.
So why did you shade it if the 7 is positive and it's asking for the negative?
Okay, well, I'm shading this way because this blob, you think of the x minus 4 being over here where I've shaded. So x minus 4 is greater than or equal to 6. Well, the x minus 4 has to be over here, this side of -6. You can see some numbers.
So if it was on that side,
yeah. So it's like x
if
minus
it was
4.
on that side,
Yeah. It's got to be less than -6. Your x itself would have to be less than -2. You're adding 4. I can put in the numbers and show you. See, x is less than -2, or this side of -2. I'm sorry, less than or equal to, or this side of -2. Well, check it out. -2 minus 4, when you put it between the bars, is that greater than or equal to 6? Yeah, you're getting a -6 greater than or equal to, yes, this is 6 greater than or equal to 6, yes. So -2 works, a -3 would work. If I put -3 minus 4, is that greater than or equal to 6? See, that's -7 between the bars.
That's 7.
Right. So any number this side, when I perform the operation of the bars, is going to work and be greater than or equal to 6.
So let's try -1. So if it's -1,
If it's -1,
rather,
-1 minus 4 greater than or equal to 6, less than -5 greater than or equal to 6. Between the bars turn it to positive, and you see it doesn't work.
right. Okay.
So then when I combine it with this, the x's have got to be this side of -2. And if I stick 10 on, closed circle, they got to be this side of 10. You can see like 12 minus 4 would be 8. That's bigger than 6. 20 minus 4 is bigger than 6. So then when I do my answer, get it up so y'all see it. I'd have to go from -infinity to -2 with a bracket, because you can use -2 because you got the or equal to. And then the other side is from 10 to infinity. That's very technical.
I'll just have to take a lot of time on that question on the test.
Sure thing.
That's hard for me.
They're either going to set up inside these 6's. If this was a less than, it's going to set up inside the 6's. But if it's greater than, it's going to set up outside the sixes, if that helps. And numbers over here, that absolute value is going to turn them positive, making it bigger than this.
That helps.
All right, are we ready for number 7? Didn't do that at 12. It's basically just straight X's with numbers. So it's a matter of moving X's to the left, numbers to the right. And then again, being able to write it in interval notation. Anybody got any interest in seeing that one?
I think I'm good.
Okay. And number 9 is another absolute value. And again, it's going to, you can see it's going to set up outside the 4s. You're going to subtract the 2 over, getting this blob greater than or equal to 4, which means the blob's got to be outside the floor this way. That's the easiest to see. Bigger than 4 is this way, but that also means it's less than -4 this way. You want to see this one done as well? It's kind of similar to number 6, but or you think you've seen enough of those?
Maybe we can, I guess, try something else.
Okay. Number 9 is a pretty simple domain question. I didn't do it at 12. Do you want to?
Yeah, that's fine. We can do that one.
You want to see that one? So number 9, domain, y equals 2 over an x plus 7. All right. You remember your domain, you've got 2 problems. I call number 1 I always do the fraction one first for some reason. So number 1, the fraction problem. Number 2 is your square root problem. Your square roots have got to stay greater than or equal to 0. And your fractions, your bottom can't be 0. Can't be 0. That's what you always look for on a domain. Well, you don't have a square root anywhere here, so you don't have to worry about problem 2. But you see you got your fraction problem. So we always use an equals. And this means when you minus 7, your x equals -7. But you see, you can't use this. Can't use this. If you do, you divide by 0. You have 2 over -7 add 7, which is 2 over 0. Just writing it down makes the math gods angry. Any questions so far before I write the answer down?
No, I'm good. I understand.
Okay. So when I come along here and I stick on a -7, if I can't use it, that's an open circle. But see, I can use, you don't have to test anything. You can use either side. And so my answer, -infinity to -7, that's the left side. Right side's -7 to infinity. You got to break it at -7. Questions about that?
Nope.
I don't think we did anything on this page at 12, so I don't know if we go down through. Do you want to see anything like 10, x and y intercepts?
Is that where you do, I'm trying to read it to see it.
Well, an x-intercept, at each intercept, the other letter is 0. So if you're looking for x-intercepts, your y is automatically 0. It's a matter of putting y equals 0 here. And
Oh yeah, I know how to do that. That's fine.
Okay. Ms. Bauer, do you need to say anything like this? Okay. So on 11 was the very first 2 formulas we did this entire semester was distance formula and midpoint formula. Do we need to remind you how those work?
I don't know if she's still there.
You know what? I've been talking to you and I kept wondering why you kept moving on, and it's because I've been muted.
Okay. Well, she's
I'm
back up.
sorry.
But no
I'm sorry.
problem.
No. I was saying it was great this whole time. I
Okay.
had muted myself because my son came in and asked a question, and I
Uh,
forgot to unmute myself.
okay, no problem. So yeah, so you get X and Y intercepts
I
and
understand all of that.
all of
Thank
that. Sure thing. The very first two formulas we did was distance and midpoint formula. Very first, section 1-1. Do you remember how those work, or do we need to walk through them again?
I remember all of the I remember all of that. My question to you is, um, so you won't give the formulas on the test, correct?
No, no need to, because like you say, online, you're at your own house, you got the book there, you can look them up.
Right. And I have my notes too. Okay.
All right, well then number 12 was circles. We did that. Can't remember 2-1 maybe. I can't remember. You remember how circles work, or do we need to remind you?
It's just a plug and play for me.
Right. All you got to do is know this circle formula.
Correct.
Right. To give you the center, the X is the H and the Y is the K, and the signs switch into the form. The formula always has minus signs, so if your number's negative with a minus, that turns it positive. So your signs are going to look opposite to what these are. And then your radius is squared, R squared, 121.
Okay.
Let's see. Okay, so on the next page, 13 is just a simple plug and chug of -5 into this formula using function notation. Anybody have any trouble with that?
I'm okay with plug and chugs.
Okay. And then
I'm
14,
good.
15, 16, 17 are about different problems with domains. 14 is a domain and a range because I gave you the graph, and then the rest of them are all just about domains. So do you need to see?
I'm pretty comfortable with that now that you explained it earlier.
Okay. See, 15 is going to have the fraction problem with the square root. Notice that the square root is greater than 0 because the square root's on the bottom. You don't have an or equal to. All right, 16's got just a pure fraction problem. You're going to set your bottom to 0, find out what you can't use. And 17 has got a straight square root problem, but you're going to have to test intervals. Oh,
18 makes me nervous.
all right, can we skip ahead to 18 then?
Angela?
Torres?
Yeah, that's fine.
Okay. All right. Yeah, this is, those graph shifts. Try to sketch the graph. Looks like we're coming up through -4. And then it's -3 up 2. And going across over to 3. Staying at 2 there. Down through 5. So this is at 2, this is at 5, this is at -4. So I'm getting, that's the original f of x. Okay, so this is f of x. So they want you to sketch y equals twice f of x minus 1 and add 4. Okay. Y'all remember what each of these, some helps me to write down exactly what each change is doing. Do you remember what the +4 out here was doing? Up, down, left, or right?
You know, I'd have to go to my notes to look at it, but I want to say it shifts right to 4.
Outside like this went up 4.
Up 4. Okay.
Inside like this with a minus sign, that went left or right.
I'd have to look at my notes, but I want to say left.
And I went right.
Right. Okay.
Minus sign inside goes right. This stretches it vertically by a factor of 2. Vertically by factor of 2.
Do you remember which chapter this was?
This is chapter, might be chapter 2. I got the book here. I think it's 2. Might be 2:6. Let me think. Try to find it. 2:4, 2:6.
Okay, 2.
Transformation of functions.
Transformation of functions. Okay.
Okay, now see here the rub. This is pretty complicated to sketch, and if you can do it all at once, all these 3 changes, you're a genius. I will bow down. I am not capable of that. I'm a mere mortal. I am not capable of that superhuman feat. And these things have to be done in the proper order, just like order of operations. So in your order of operations, you know how you multiply first? You can think literally of these things as adding and subtracting. So you're supposed to multiply first before you add and subtract. And to really show it, I would draw that first, because that graph with this multiplied by 2 is what's going to be shifted right 1 and up 4. And just to get some coordinates here, I'm going to call this coordinate -4 and 0. This one's -3 and 2. Over here, you're at 3 and 2, and this one's at 5 and 0. Because if you're going to, my first cut at this, then I'm just going to sketch y equals twice f of x. Which means I'm multiplying y coordinates by 2. Remember, f of x is a y coordinate. So I've written the numbers down to try to make it obvious. Multiplying y coordinates by 2, see, that's not going to change. Multiply the y coordinate by 2, 2 times 0 is 0. But up here, you're going to get -3 and 4. Here, you're going to get 3 and 4. And here, this isn't going to change. It's going to stay 5 and 0 because 2 times 0 is 0. All right, does this make sense? Go ahead.
Did you use a calculator at all when you got this f of x
Oh,
to y
this is
equals
given.
2 of x?
You can't use a calculator. They don't give you a formula for this.
Okay.
So this is an exercise and just here's what the graph looks like, and can you draw it with these changes? So what I did was I picked off points off the curve. That's what these are. And then to make this first change, I'm multiplying the y coordinate of these points by 2. Let me
Okay.
sketch it out. We'll see if you get that. So the -4 0 doesn't change, but the point at -3 2, so you multiply that y coordinate by 2, 2 times 2 is 4. So that goes to 1, 2, 3, 4, -3 and up 4. This one went to 3 and 4. And the 5 0 still doesn't change. Can you tell it's been stretched up by a factor of 2?
I can see that. I can see that it's been stretched vertically by a factor of 2. Where I have difficulty is understanding how it's the +4, where that came from.
Oh, see that, I'm ignoring that. I'm at the moment, I'm doing this operation first.
Okay, yes, I can see that.
Okay, now I'm ready to shift it right 1 and then up 4. But this is the curve that has to be shifted right 1 and up 4. If you do the right 1 up 4 on this graph first, and then you multiply it by 2, it's completely screwed up. It's out of order. Now, the order that you do the right 1 and up 4 doesn't matter. You'll get to the same place. Are we ready to move this graph right 1 and up 4?
I am.
Okay, so we're going right 1 up 4. Can you do that kind of all at once? I could spread it out. Do it right 1 further, then up the 4, but can y'all handle moving these points right 1 and up 4? All at
Yes.
once? Okay, let me try to keep it on the same thing. So that's gonna wind you with a graph. All right, so your 5 and 0 is gonna come into 4. Because it's right 1, and then it's gonna go up 4. So 1, 2, 3, 4. I think maybe I should have started a little further down the page, because let me try a little further down the page. Okay. So this point right here is going to move into actually 3. Okay, into 3. And then it's going to go up 4 because it's on the axis, going to go up 1, 2, 3, 4. So it's going to go there. All right, then this point is going to move into 2. And it's going to go up. See, this is at 4. It's going to go up 4. So it's going to go up to 8. 2 and 8. All right, so I'm sketch the curve. Are we losing anybody?
No, I'm still here.
So it's going to
I'm
go.
still here.
Okay, sure thing. So, well, I really meant losing you in terms of this problem, I guess is what I really meant.
I'm with you on the problem as well.
Okay.
Yeah, I'm listening.
All right, sure thing. So this was at 3. It goes right 1, it goes over to 4. And it's still up to 8 because it's horizontal across. It's still at 8 up there. And then this point went right, so let's go over to 6, and then up to 4, being at the same level as this one is. 5, 6, and then up to 4. So it's on kind of the same level as that. It looks something like that. I could write out the numbers if you want to see them.
You mean the coordinates?
I actually could, write out the coordinates. I always write out the coordinates if I'm going to do a multiply step. But I usually never do if I'm just shifting right 1 and up, left or right or up or down. But I could if you want to see them.
I think I understand. I mean, it's just like if this were a computer, for example, it would literally just shift it up and over to the right
That's right.
on this graph.
That's right.
Okay.
All right,
And it's
let's.
the same shape.
Okay. I don't know how, let's see, we're at 53 minutes. We can keep going as long as y'all want. 19. Do you want to see 19?
Is that about the same as 14?
I can't remember.
I mean 18, sorry.
I was gonna say not no. G of x equals negative x to the 8th power plus the absolute value of 3x.
Yes.
Is g of negative x the same as g of x? Is that what you're asking?
That's what we're asking. You want to see that plugged in and see?
Yeah, would you mind if we just worked that one really quick?
Sure thing. Okay. Okay, so yeah, it's g of x 19. G of x equals a negative x to the 8th and add an absolute value of 3x. Okay.
I have a
Yes.
not like I don't know if it's like a question, but like I kind of want to. So is what it's what it's explaining? Is it that when you basically change the parentheses where it shows the parentheses negative x and then the 8 outside, it's basically showing the same thing that the negative x on the other one is the same, except the 8 is just on the outside, but the x is still negative, and then on the 3 it makes it a positive. You get what I'm trying to explain?
Yeah, exactly. The bars turn it positive. Yeah. You can see it from here. I put in a negative X where there's an X. So a G of negative X, you want to see it written out again. Let's see, would take, you have this negative, I'm going to stick a parentheses and put in negative X where that X is, and that's raised to the 8th. Add a absolute value 3 and then a negative X there.
So basically, it's the same thing. The only thing that's different is that on the bottom one, the bars make it positive, so it'd still be the same as the top. And then the bottom one is the same as the top. The only thing that's different is that the 8 is on the outside of the parentheses.
Yeah. See,
Okay.
yeah. In effect, that's a negative to an even, which is positive, which is identical to this, but this outside negative is still there. So this doesn't change. And then, yeah, the bars turn that negative positive.
Yeah, that makes sense.
So this means that your G of minus X is equal to G of X, or you could reverse it, G of X equals G of negative X. And that is the definition of an even function.
So G of negative X is always equal to G of X.
No.
No matter
No.
what the number.
See, there certain functions are even and certain ones are odd. Basically, it says in plain English, if I put a negative X where there's an X and it doesn't change anything, that's even. The simplest one is X squared. Let me do the really simple ones. X squared. Do you remember that looks like your parabola here?
Yes.
Okay. So I can do an X and I get an X squared. If I go the same distance and that's negative X, and I come up here, I get a negative X squared. But you see that negative X squared is still X squared?
Yes.
So basically I'm putting in a negative X and nothing changes. I get the same thing. This is the definition of even. Formally, if this was an f of X, your f of X is equal to your f of negative X.
That makes sense to me.
Okay. But no, it isn't always the case. Once, basically on an even, both sides are up or both sides are down. Odd, just for completeness, one side can be up and the other side down. This would be X cubed. I'll show you. So if you have an X, you come up and you get X cubed. Go the same distance minus X and you come down and you have minus X cubed. Well, negative to an odd power, that's a negative X cubed. You see how you wind up with something negative to what you had?
Yes.
That's the definition of odd. So if a
I
function
see. Okay.
doesn't, they usually give you 3 options, even, odd, or neither. So if it doesn't fit either of these cases, then they call it neither. It's just a random thing. And notice the odd X power, the odd exponent, odd, even exponent, even.
Okay. I can live with those rules.
Okay. Now that's by themselves. Again, there's always complicated thing. If I mix it, this will be a neither. Because signs will switch among it. I won't write down the gibberish to show you. Did you kind of believe if you this is when you mix it, you get neither.
Okay.
Let's see. Do we need to move on here? We're at about an hour. We're having so much fun. Okay. All right. So 20 was to, if you remember how to figure this out, you plug G into F, plug this G into that F, and they want you to figure out the domain.
I was okay with those problems.
Okay. It works
It's
out.
complicated,
Right.
but it works.
Right.
It still comes in play.
Okay. Basically, you had a fraction problem on the domain. You can't use -3. 21 was a parabola problem. That was section 3.1, I believe. There's formulas for vertex of a parabola and y-intercept. You don't really have a formula. You have to just know what to look for. We need to go over parabolas again.
I'm okay with parabolas, Mr. C.
I'm
And how
good.
about Ms. Torres? You need to see parabolas?
I'm good.
Okay. So this is where the person at 12 o'clock wanted to see a lot of these. So I did wind up doing 22 at 12. I did 23 and I did 24. I did this whole page at 12 o'clock. Y'all want the instant replay?
Did you post them at on your Zoom?
Nope. I got the video posted to YouTube.
I'd love to go over something you didn't post on your Zoom.
Okay.
Personally.
All right. So I did all 3 of these. I did 25. She wanted to see most of everything. Okay. I did not do 26. You want to see something like 26? It's
Yes,
a little
please.
worksheet about this graph. Let's see if I can quickly get you that graph. All right. Basically, at 3, this would be your vertical asymptote, and they're crossing at 2 and approaching. Going down to -3. And that would be your horizontal asymptote because this is coming down and approaching it there. And then 4, 5, they're crossing here and then approaching the same thing there. So the little worksheet is domain. Part A, domain. All right, well, there's no formula to read about fractions and square roots. You just got to think, okay, you're starting at negative infinity. Remember, you're going x min, x max. So you're starting at negative infinity, and it looks real good until you see how you hit this vertical line at 3, and it bends to it. That means you're not using 3. Because you're not Christ. It doesn't do this. If it did this, you'd be crossing 3, and 3 would be in. But it bends to it and never gets to 3. So we're getting to 3, and you need a parentheses there, and you see you need a parentheses there. It doesn't do this. All right, then you pick up the other side of 3. On this, it's approaching 3. You're doing a 3, and you got no problems, and it's going all the way out to infinity. And you'll use the parentheses there and there again. They usually stick a U between them. Basically saying you're using any number but 3. Questions about that?
I'm good.
Okay. B is your range. Once again, that's a Y min, Y max. Well, you got to think up and down. Domain, you're thinking horizontal. Range, you're thinking vertically up and down. Well, there's nothing down here. You don't pick up anything until you start at -3. But again, see how they're bending to -3? They're not crossing -3. So you're going to start at -3, but use a parentheses. And it goes all the way to infinity. You got no problem. It goes all the way up to infinity. Questions about that?
I'm good. Thank you.
Okay. So C asks for the vertical asymptote. Already identified them. That would be x equals 3. I've named by the x coordinate there. And D asks for the horizontal asymptote. Well, I've identified it here. That's the line horizontally they're approaching. That's a, see, those are y, that's a y value. Y equals -3. Did not do 27. That's a kind of a quadratic inequality. Going to have to factor it, get your numbers here, stick them on a number line, and then test. You want to see anything like that? Not hearing anybody. Y'all muted or anything? Do we need to see 27?
I thought I muted myself. Sorry. I was trying to say that. I was trying to read through it.
Okay. You basically got to factor it. You'll switch the signs. That gives you the 11 and -1.
Yeah, I think I'm good.
Think you good with that? How about Miss Bauer? You need to see anything like 27 or?
Yeah. Oh, yeah. Sorry, I actually just came back online. I lost battery power and had
Oh,
to re-enter Zoom. But yes, I mean, so anything. I mean, I don't want to keep you, but gosh, yes, any extra
okay. Well, did
that
you have
you
any?
want to go
Yeah.
over 27 would be great.
You want to see 27?
I have
Okay.
a question. Will you go over, well, not all of them, but most of these next week?
Yeah, I will go up. Yeah, I'm planning on holding the regular schedule of Zooms Monday and Tuesday. Like I said, I expect, I don't know if, more people will show up, but I bet there'll be, if they do, they'll be a lot more serious about it since the final exam will start Wednesday. And so, yeah, I will
Okay.
answer
'Cause
any.
I have to head out and
Yeah.
I don't want to
Sure.
miss anything.
No, I will, you show up and ask me about any, even if I've already worked it tonight, I'll work it again. I've got infinite patience, 33 years here.
I have all the questions that I got wrong on all my tests and all my quizzes.
Okay.
So I certainly wouldn't, but like if I were to maybe ask, I mean, if I were to ask you some of those questions at some point, maybe not tonight, if I know you don't have time tonight, but maybe next week.
Yeah, probably don't want to do that during the regular Zoom since they're specific to you. Why don't we
Okay.
set up, send me an email, remind me. We'll set up I'll send you a special link and we'll have a personal Zoom, say at 8 o'clock.
That's fantastic. Yes, I would love to. There are some that I really don't know how I got them wrong or what I did wrong. So I think if I could get those right, I would feel better about the test.
Sure thing. Yeah, I'll send you a link. I'll schedule a Zoom meeting at 8 o'clock. That'll be just for you. And yeah, I'll send you the link to it. And yeah, you can ask
Okay.
any questions.
Did you mean tomorrow morning or another day?
No, actually, I meant 8 o'clock next Monday. Is that okay or is that too late?
I will be there. Absolutely.
Okay, sure thing.
Okay. Well, thank you so much. I appreciate it.
Absolutely. Are we done tonight or do you want to see more of these?
I'm okay tonight, Mr. C.
Okay.
Same here.
Sounds good then.
All right. Thank you so much.
Thank you.
Sure thing. Y'all have a good Thanksgiving.
You too.
Happy Thanksgiving. Thank you.
Okay.
Bye-bye.
Bye.